So we have a bouquet of 4 roses and 8 carnations, cost $14, and a bouquet of 6 roses and 9 carnations costs $18. How much do 1 rose and 1 carnation cost? So we're asked for 2 things. We're going to let them be x and y. So we'll say x is equal to the cost of 1 rose, and y is equal to the cost of 1 carnation. So 4 roses will cost me 4 times the cost of 1, 4 times x. And 8 carnations will cost me 8 times the cost of 1 of them. So if I had 2 of them, I would multiply by 2, 3 of them by 3, and so forth. So 8 carnations cost me $8. And apparently together, this and this cost 14. So I'm going to add them and equal it to 14. Similarly, 6 roses and 9 carnations cost 18. So 6 roses cost me 6 times x dollars, plus 9 carnations is 9 of them times y dollars, equals 18 bucks. Now I'm supposed to solve this system by the graphing method. So in order for me to solve this by the graphing method, I would like to get each of the y's alone by themselves. So I'll make them in different colors. We'll have, we'll have the first one in red and the second guy in green. And then we'll graph each one carefully and see what the solution is by the graphing method. So let's start with the first one. I'm going to subtract 4x from both sides. 8y, negative 4x plus 14. Divide everybody by 8 and reduce accordingly. So y equals, this reduces to negative 1/2 x, because divide by 4, 1, divide by 4, 2. Plus, these are both divisible by 2, it looks like. 14 divided by 2, 7. 8 divided by 2 is 2. So there's the first one that I need to go graph. Let me get the second one ready as well. So 6x plus 9y equals 18. We're going to get the x's on the other side. 9y is negative 6x plus 18. Divide everybody by 9. We got y equals, divide top and bottom by 3. Negative 2/3 x plus 2. So I'm ready to graph these two. The second one's easier to graph because the y-intercept is a whole number. This one will require a little bit more care. So let's go start with the second one. The y-intercept is 2, so on the y-axis I'm going to go to 2. And then it says to go down 2 and 3 to the right for the slope. Notice I'm not going to go down 2 like this because that's a half step based on the scale they gave me. From 2 to 1 is 1 full step, and then another full step, and then 3 to the right. 1, 2, 3. So there's my line. The line would extend up and down, however, I'm dealing with the context of this problem, I'm dealing with positives, it looks like, because I can't have negative dollars and I can't have a negative number of roses or carnations. So I'm just going to put it in quadrant 1 only. Let's go graph the second one. Before I graph this, I actually have a mistake here. Let me fix that guy. If I'm dividing 14 by 2, I get 7. If I divide 8 by 2, I get a 4. So that's going to change things. I got to be careful. Now 7/4, how do I graph that on the y-axis? Well, 7/4 is really just 1 3/4, which is really just 1 and 0.75. So all I'm looking at is 1.75, where my starting point is on the y-axis. So again, even if you take your calculator and say 7 divided by 4, you're going to get 1.75. So I'm going to go to for the y-axis on 1.75. Here's 1. Here's 1.5. 1.75, I guess, is somewhere there. That's my y-intercept. Now from there, I have to take care of my slope. Go down 1 and 2 to the right. Now be careful how you go down 1. Make sure you go down 1 full step. So I have to start at 1.75 on the y-axis again. Let me get rid of the green line, maybe. I would rather do the red one first because this might cloud how I'm going to show this. Let's go back, change my mind. start graphing the red line first. The y-intercept is 1.75, so there's 1, there's 1.5, there's 1.75. That's the y-intercept. Now, the slope tells you to go either up 1 and 2 left, or down 1, depending on how you want to look at the negative, and 2 to the right. So let's go down 1 and 2 to the right, and I have to do it carefully. Again, I may have to approximate things and not get an exact answer because I don't have a ruler here. So from 1.75, if I want to go one step down, make sure you don't go there because you've only gone a quarter down. If I go to 1, I still have not gone down 1, I've only gone 0.75 down. So be careful, you're going one full step down. So one full step down would be somewhere there. I'm going to make a mark and get rid of it, of course. That's one full step down. And then 2 steps to the right, the grid tells me 2 full steps. That's one full step, that's another full step. So somewhere there is my other ordered pair, and I'm going to get rid of this. So again, the red line caused me to start at 1.75 and then go one full step down and 2 full steps to the right from there. I would repeat the same thing and go one full step down and fall a little bit below and then go 2 to the right, but again, negatives don't really make sense here, so I'm going to try my best to draw a line as straight as I can for the red one, using this ordered pair and this ordered pair. Now let's go back to the green one. That was quick, and see what we can do. The y-intercept is 2, and 2 full steps down, 3 steps to the right. 2, 1, 2, 1, 2, 3. So my red line connecting the 2 dots to the best of my ability, something like that. So, as you can see, the graphing method can cause some issues because I know it happened, the intersection happened somewhere here, but I'm not too sure. If I were to guess, I would say, okay, I think the intersection happened maybe right there. If I guess that to be the intersection, then the x-coordinate looks like it's a 1.5, and the y-coordinate looks like it's a 1. But again, I'm not 100% sure because I totally approximated things here. So if I've done my graph correctly, or accurately rather, x is 150, that's the cost of 1 rose, is $1.50, and y, which is the cost of 1 carnation, is going to be $1. So again, I'm not too sure. I did this by hand. I'm going to go look at these, put this guy, the green line and the red line, into my graphing calculator and see what the intersect feature gives me there. Another thing, of course, I can do is take this x, take this y, plug it into the first equation, plug it into the second equation. If I get a true statement for both of them, then I know for sure my graph was accurate and I did it correctly. Let's go check quickly on the TI as well. Okay, so I'm going to put the first one, which was negative, remember that's the negative sign, negative 1/2 times x plus, it had a y-intercept of, what was it, 7/4, I think, 7/4. I could put it in parentheses or not, it's just going to add it at the end. And then the other equation in green that we had was negative 2/3 x plus a nice y-intercept of 2. So let's graph these two. Definitely looks like they're going to intersect in the first quadrant. Let me fix the window to be the same window that they gave me to do by hand. I'm going to go 0 to 4 and 0 to 4 again for my y's graph. Okay, so that looks pretty much like what we did by hand, but now let's go to second trace. Number 5 is what I'm going to select for the intersect feature. It asks me, is that the first curve? It's this guy that I put in. I'm going to say yes. Then it jumps to the second curve. It displays the equation, is this the guy? And I'm going to say yes. And then it says, do you want me to guess the intersection? I'm going to say yes. And yep, it looks like we graphed it accurately. The x is 1.5 and the y value is 1. So we're good to go. Okay, let's look at another example. It says Yasu can afford to produce 50x bushels of wheat if he can sell them at x cents per bushel. And the market will buy this many bushels at x cents per bushel. So we got to come up with the supply and demand equations that you did in the reading. So we got this many that if he produces that many, he can sell them at x cents. So the supply equation will say x is the price of bushels of wheat, which is what they tell us, and then we'll let y be the number that he can afford to produce. So basically, y will be the number of bushels of wheat that are produced. If he produces so many and the market will buy that same amount, then we've reached the equilibrium point. So the supply equation is what Yasu can afford to give. So they tell us right here he can afford to produce this many. So we'll say y is equal to 50x. This is the number that he will supply or give. And at that x cents, the market will buy, the market demands this much. So the market wants this much. Still, y equals 2100 minus 20x is going to be the demand equation. So y is the number of bushels of wheat, and he can afford to produce, or in other words supply, 50x of them, and the market at price x will buy 2100 minus 20x of them, that many of them. Now when I graph both equations in this window, actually that's important that they're giving me the window, because if I just go to my basic window, it's not going to display everything nicely because these numbers are going to go beyond -10 and 10 for the x and y axis. So let's go graph both and then analyze what happens. So I have both of the equations, the supply equation and the demand equation, input into the calculator. I'm going to go to the window and use the window that they want me to use. So 0 for the x, 120 for the maximum x, that was the minimum x, 0 for the y min, and the y max, 2500. I'm going to graph this guy. There is my supply equation and there's my demand equation. Things make sense because the supply has a y-intercept of 0 with a slope of 50. So it starts at 0 and shoots up in the air. The demand equation has a y-intercept of 2100 and a negative slope of 20, so it shoots down. Now where they meet will be the equilibrium location. So part D asks us find the equilibrium price and how many bushels he can sell at that price. Well, equilibrium price means the supply and the demand equations meet, so whatever he supplies, that's exactly what people are demanding. So let's go to second, trace, number 5 for the intersect feature. First curve, yes. Second curve, yes. Do you want me to guess? Push enter again, yes. And it gives us the value 30 and 1500. So let's write that down and analyze it. 30 and 1500. So we got x is 30, whoops, and y is 1500 from our intersection feature. We didn't graph it by hand, we used the TI. X stood for the price of bushels of wheat, and since where they intersect, they both meet each other and hit the equilibrium price. The equilibrium price is $30, and at $30, he will be able to sell 1500 bushels of wheat. So he will price it at 30 bucks and 1500 people will buy it. Scratch that, not 1500 people will buy it. He can sell this many bushels. Let's go write a sentence to clarify that. Okay, so let's go state exactly what we found. The equilibrium price is 30 cents per bushel. I have to go back and make sure I was getting sloppy in my interpretation. It says X cents per bushel. So the equilibrium price is 30 cents per bushel. And at 30 cents per bushel, he can sell 1500 because that stood for the number of bushels of wheat, 1500 of them.